Hello, everybody. Today we are going to be going through some more of the templates and tools that are available to help you with quantifying values for your robot designs that would go into your decision matrices. So this first Excel template, all of these different templates and tools are available both on Canvas, um, in the DR2 module, as well as on the course website under Design Project Resources. So you can find all of these there, whichever way you choose to find them. They are both the same document, or they should be the same document in both places. What we are starting with today is the wheel speed and robot time calculations template. So this template, again, the first page has important notes for you to go through and read on how to use the template, and then we can go on to the next page of the template and see the actual calculation spreadsheet for doing this. So at the top of the spreadsheet, we have a whole bunch of different options that calculate out using an approximated 75% velocity for the load on the robots, which is a reasonable approximation to make, for a couple of the different motor and wheel combos that we have in the lab. And then down here at the bottom, you can see there are 4 spots for concepts. If you come up with a 5th concept for your own group, you should go through and change it. On a bunch of these cells, there are comments made by Mike Braddock that go and say what each thing goes into. So for concept 1, it tells you that this is the average velocity for the first robot concept. So he comes in, we pick out what the motor is, what its RPM is, the wheel diameter we're going to go through with, and it'll auto-calculate out these values for us. You need to input. These values in red will change based off of what you choose for your robot and for your concept. And then the average robot velocity comes from a table below, which we will get to in a second. But all of these red values are things that you are going to have to change for your own specific designs, for your own concepts going across the board here. So things like maneuvering time to approach the bucket, dispensing time. These are all estimated amounts of time that we expect you to come up with. Just think a little bit about it. We also have realistic minimum and maximum times, where you can update what you think the time to complete and the minimum and maximum time to complete should be for the design. And if a design goes over that, or if it is within the range, it will actually conditionally format the estimated competition time to be yellow if it's less than, green if it's within the range, and red if it's over. Now, back to this section where it says that it comes from the driving parameters. We also have a table in here for driving parameters. So when you are creating your path trajectory, which you should have already done as a part of DR1, you can break down how fast do you think you're going to be driving at each one of those sections. Am I going to be going 100% velocity, or am I going to be going at 50% because I need to maneuver closely? So for the segment that goes, straight over the first ramp, 100% velocity, great. But now, as I hypothetically am approaching the first bucket that I need to pick up, or that I'm going to pick up, I'm going to be slowing down because I need to be turning around and maneuvering myself. And then when I get really close, I'm going to really be slowing down even more and more and more so as I go and maneuver and get closer to things, et cetera, et cetera, et cetera. So you can fill in for all of these paths. If you need to create additional columns, you can create additional path columns in here. Up at the top, you will note that this is the, it actually calls the cell up above, so it actually pulls in what the maximum loaded velocity would be from concept 1's design. And then this 44 is a rounded up value from my value down here that comes out as my average robot velocity. So you can get all of this stuff to pretty much auto-calculate for you, with you putting in your estimates of reasonable times, your own design concepts, and everything that you need, to do for this competition. So this will help you get your estimated competition time out of this. So take the time to review this, read all of the notes, and go through everything here so you can understand using this document. So next up on our list of templates to go through, we have time estimations for manufacturing times. This is particularly challenging because this semester, with the course being online, you're not able to be in working on the machines to get a feel for it. However, we have a template here for it, and we have another example document that I will go through in a second, where for each part that is being manufactured, that is going into, or for each assembly that is being manufactured, you can go through and take in the processes that would go into manufacturing it, the estimated time from our template sheet that we have and the examples that we have. Again, use them as reference, and get a subtotal for each one of the designs. So this has design 1 and design 2. You can just copy and paste below for subsequent designs for both individual parts as well as total assembly. So the instructions are here, but let's look at the example for it. So the example for it is also on Canvas and on the website, as I have mentioned before for all of these. We can see we have a whole bunch of examples. The shaft clamp bracket and the wheel hub are the two assigned parts for the class that traditionally get made as a part of the lab sections in the first few weeks. We have here the list of processes, then the steps that are gone through in the course of making the part, with the estimated amount of time for either a beginner, being somebody who has just walked into the lab for the very first day and is going through it with the TAs showing them, or then intermediate, being somebody who has learned how to use the machines and has been paying attention and should be a little bit more proficient with doing it. So we have examples for the shaft clamp bracket, for the wheel hub, an example motor mount bracket, the wheel hub for the N-Stort motors, an example sheet metal part, an example assembly being a mobile platform assembly, to help you with figuring it out. And then the very last page is the full list of processes that we have specified times for. So when you are going through this, you can take these processes and go back into our template document here, and you can switch over into the template and take those processes and times to build out your estimated times for an individual part or an individual assembly. So that wraps up manufacturing times. The last thing is cost. So here we have our cost spreadsheet. It goes through for each design, the material that is used for that design. Again, this is for a mobile platform, to keep true with our example. So we have all of that there for the different costs. It's just a single simple sheet. You can copy and paste this vertically for each design, and then add in columns for additional ones, or provide additional tables for other subsystems, other subsystems down below. There's a note here that the cost is calculated using the price material list. That material list is provided on the course webpage and on Canvas. Again, I believe it's actually the course webpage is linked through Canvas. But here is the material that we have in stock in lab and the price per foot. So if it is not something that we have in stock, there are also 3 websites linked in the PDF for you to find materials and sizes that are not stocked in lab, and then an example for how to compute the cost for material that's not on the price list, or when you're using an intermediate length of the price foot of it. So if you're using something that's in between 1/8 inch by 2 inch and 1/2 inch by 2 inch, so let's just say you want 1/4 inch, how to calculate what the price would be for that material per foot to be used on your robot and in your cost analysis. We also have the list of pricing for sheet metal that we have in lab. And again, other places that you can check out, I believe Lowe's and Zell's or Ace Hardware have sheet metal online as well, so you can check out their websites. And then these are 2 local welding shops that you could contact, or you can look up on McMaster-Carr, Online Metals, or MSC Direct. And then again, another example for how to compute the cost for in-between sizes in different areas of sheet metal that you need to use for calculating cost for the to put into the template spreadsheets that we have given you. So now I've mentioned that all of this is posted up on Canvas and on the course website. Where on Canvas, where on the course website? If we come to the Canvas page and we go under modules, and we go down to the DR2 module, because that is the portion of the course that we are going into, there is a page created for templates and grading criteria that has the decision matrix template, the examples that I mentioned and went through in the previous video, the cost template, the things that are going to go into Appendix A, the time estimations for manufacturing parts are also included on here, as well as a link to the page for robot speeds and motor torques that has the path template for planning out your path, as well as the spreadsheet that I went over at the beginning of this video to find wheel and motor speeds and time calculations for that. As far as on the DML website, if we come over to the DML website, we go to Design Project here on the left-hand side, Project Resources. We can scale down to Design Report 2, and you can see all of these same templates, same guides are all posted here for you to have access to on either the website or on the Canvas page, whichever one is more convenient for you to use. So with that, happy decision matrixing. And as always, feel free to reach out to myself or any of the TAs if you have questions or need help.